Quantum physics is not only well understood by scientists, it's also one of the most precisely tested theories in science, underpinning the creation of numerous technologies we rely on today, like computers, lasers, and nuclear reactors. This branch of physics zooms in on the universe's tiniest constituents, molecules, atoms, and subatomic particles. At this microcosmic scale, the rules we take for granted in our macroscopic world don't quite apply. Every visible thing, including ourselves, is composed of quantum physics in action. In explaining quantum behavior, protons, neutrons, and electrons are typically depicted as waves rather than discrete particles. For example, while we might think of an electron as a small sphere orbiting an atomic nucleus, quantum mechanics describes it using a mathematical wave function. To deduce properties like an electron's position, we perform calculations on its wave function, which shows where it's more likely to find the particle. Quantum physics proposes a universe where events are not precisely determined, but are dictated by likelihoods. The wave function predicts subatomic behavior quite accurately. Yet, we don't know exactly if wave functions are physical realities or just mathematical tools. This enigmatic bridge between the quantum realm and the world we observe involves a process called a collapse and is known as the measurement problem. This particle-wave duality is demonstrated in the double-slit experiment. When electrons pass through two narrow slits, they don't create two distinct impact points as particles might, but instead form an interference pattern indicative of wave behavior. Yet when observed, each electron manifests as a single particle, not a spread-out wave. From this emerge phenomena like superposition, where particles exist in a blend of states at once, or entanglement, where particles stay connected over vast distances, or quantum tunneling, allowing subatomic particles to pass through barriers. Expanding with string theory requires a shift from the traditional understanding of particles. According to string theory, the most fundamental constituents of reality are not particles, but rather tiny strings that vibrate. These vibrations give rise not only to the particles we've identified in particle physics, but also to the very forces that govern their interactions. These vibrating strings exist in 11 dimensions, most of which are beyond the reach of our current experimental capabilities. Our everyday experience is limited to 4 dimensions, 3 of space and 1 of time. Yet, string theory suggests that the remaining unseen dimensions could hold the key to an understanding of all forces in nature. The concept of parallel universes, or a multiverse, arises naturally within the frame of string theory and its interpretation of quantum mechanics. With each quantum event, reality potentially branches off into a multitude of possible outcomes, each one representing a different version of the universe, a concept known as the many worlds interpretation. So while we perceive a singular outcome when we observe a quantum event, other possible outcomes are theorized to exist simultaneously in alternate universes within the multiverse. Turning now to biology and the other realms of science, the question remains on how, or if, these other dimensions have any influence. Will the principles of quantum physics shed new light on biological processes at the cellular or molecular level? Could observing phenomena like photosynthesis, enzyme reactions, or even neurological activities lead us to discover quantum effects within the living organisms? These are intriguing possibilities that researchers are beginning to explore, blending physics with biology. In our upcoming episode, we'll delve deeper into the potential quantum nature of life and the universe. What can string theory and quantum mechanics teach us about consciousness, the origin of life, or the possibility of life forms perceiving more than the 4 dimensions we're accustomed to? Do living beings inherently interact with the quantum world? And if so, what does that mean for our understanding of reality?